Hey guys, today we're going to talk about parabolas. You'll be able to determine the relationship between a parabola and its focus and its directrix, and you will be able to derive the equation of a parabola given its directrix and its focus. You will also get familiar with the different parts of a parabola. So first, let's talk about a parabola, which is the set of all points in a plane that are the same distance from a given point called the focus and a given line called a directrix. A parabola has an axis of symmetry, which is the line that divides the parabola into two symmetric parts. This line passes through the vertex and is perpendicular to the directrix. The vertex lies on the axis of symmetry and is halfway between the focus and the directrix. So if we look at this graph here, we have a parabola, which I will outline now in blue. Our focus point is right there. And our directrix line is the green dotted line. The distance from any point on a parabola, we have this point chosen. The distance from this point to the focus and the distance from this point to the directrix will always be equal. We also said that from the vertex, which is the maximum or minimum of a parabola, the distance from the vertex to the focus and to the directrix will also be equal. So, since we know that there's a point in the parabola that's the same distance from the focus and directrix, we can use our distance formula, which is the square root of x minus x1 squared plus y minus y1 squared, to derive the equation of the parabola. So if we have the focus of 0, 2 and a directrix of -2, we are going to derive our equation for this parabola. First, we're going to set up the distance formula for the focus and the parabola. So the focus to the parabola, or to the vertex, which is our point in the middle, would be, our point parabola is x, y. The focus is 0, 2. So the distance formula that represents this is the square root of x minus 0 squared plus y minus 2 squared. Then you want to set up the distance formula for the directrix and the parabola. So once again, the point on the parabola is going to be x, y. And the directrix will be y is equal to -2. So the point on the directrix we will use shares the same x coordinate as the point on the parabola. So our point that we're going to use from the directrix is x, -2. We're then going to do the distance formula using our 2 points. So we're going to have the square root of x minus x squared plus y minus -2 squared. We are going to take these two equations and set them equal to each other and solve. So we have the square root of x minus 0 squared plus y minus 2 squared is equal to the square root of x minus x squared plus y minus negative 2 squared. If we simplify this, you get the square root. X minus 0 is just x, so we're left with x squared plus y minus 2 squared is equal to the square root. X minus x is 0. 0 squared is still 0, so we don't have to write anything there. And then we have y minus a negative, which is plus 2 squared. In order to get rid of our square root, we're going to square both sides. When we square square root, we're going to be left with what's on the inside of our square root, so we're left with x squared plus y minus 2 squared is equal to y plus 2 squared. We need to FOIL these. So this is the same thing as y minus 2 times y minus 2. So we have x squared plus y squared minus 2y minus 2y plus 4 is equal to y squared plus 2y plus 2y plus 4. Combine like terms. We have x squared plus y squared minus 4y plus 4 is equal to y squared plus 4y plus 4. Going to continue to combine like terms. Going to add 4y to both sides. Sorry, that's going to. Going to subtract y squared from both sides. Y squareds are going to cancel. Going to subtract 4 from both sides. The 4's are going to cancel. So what we are left with is, on the left side of the equation, x squared is equal to 4y plus 4y is 8y. To get y by itself, we divide by 8, and we get y is equal to x squared divided by 8 as our equation of this parabola. We're now going to talk about characteristics of a parabola. So we have two different ways we can write the equation of a parabola. So we have general form and we have vertex form. General form is y is equal to ax squared plus bx plus c. And vertex form is a little bit different, where y is equal to a times x minus h quantity squared plus x. The vertex form for the equation of this vertical parabola is telling us that we have a vertex of hk, and this table here is going to give us information about our parabola. So the variable p, when we see p, it represents the shortest distance from the vertex to the focus and to the directrix. And when a parabola is written in vertex form, we can easily identify these following characteristics. So the equation of our parabola would be y is equal to 1/4 p times x minus h squared plus k. the vertex we get is from H and K. So H and K, or H and K. If we want to write the line, write the equation of the line for our axis of symmetry, what we would write is it's a vertical line, so its x is equal to h, because it's going through the x coordinate of our vertex. So we're also going to use h to write our axis of symmetry. Our focus, which is also aligned with our vertex and axis of symmetry, is h, and then our y coordinate is k plus p. We're going to get p from using a and 1/4 p. Then we have our directrix, which is a horizontal line, so we have y is equal to, and now we're going to have k, once again, which is our y coordinate of our vertex, minus p. Then if p is positive or greater than 0, our parabola will be opening up. And if p is negative or less than 0, our parabola will be opening down.